you should be sitting down in front of your computer or iPad or whatever you choose to watch the videos on, and you should be excited. This is the last set of notes and the last video that we'll take for Unit 5. It also is the one that relies the most on your background knowledge, so it should go pretty well. As you can see, instead of working with systems of linear equations, today we're going to talk about systems of linear inequalities. And you actually have quite a bit of background knowledge on just graphing regular old linear inequalities. And I think once you see just this graph right here and you kind of think back to what we talked about a little bit last year, you'll see that solving and showing the solutions for these systems is very, very simple. Before we do that, do have to background knowledge check a little bit and make sure that we know what we need to know for just linear inequalities. So the first thing I want to do is tell whether a solution is tell whether an ordered pair is a solution of a given inequality. So if I'm looking at 0, 1, is that a solution of that given inequality? Remember, we can just substitute to check and see if this works. So I'm going to put 0 in for x, I'm going to put 1 in for y, and then we're just going to see if this actually gives us a true or false statement. 0 minus 3 gives us a negative 3, and so notice, since that gives us a true statement, we would say that yes, that ordered pair is a solution of that equation. Now that's not the only solution to that inequality. It actually has infinitely many solutions, just so long as they fit that requirement, and that's what we should remember from last year. Another quick background knowledge check. Just some main things that you're going to want to know to make these things a lot easier for you when you're trying to graph them and when you're trying to solve them. I would highlight a couple things here. Just make sure we remember slope-intercept form is y equals mx plus b. When we look at that, remember then that m would be our slope and b would be our y-intercept, and we can use that to graph. The other things that we might want to look at as far as making sure we understand that is just all of this here as far as the different symbols of inequalities and how we graph them accordingly. Remember, if it's a less than or equal to symbol, then we will shade below. And then if it's a greater than or equal to symbol, then we would shade above. And then we just got to remember if the line was solid or dashed, we would have a dotted line if it can't be equal to. We would have a solid line if it can be equal to. And this should come back to you as you watch some examples and as we work through this. But just trying to remember how those symbols of inequalities affect our graph. So a quick review of what we did last year. If I just gave you one inequality that I wanted you to graph, not a system, but just one inequality that I wanted you to graph. Well, in this case, it's not in slope-intercept form. So the first thing I would want to do is maybe try to get that in slope-intercept form. So I would have 2y is less than a negative x plus 6, try to get y by itself, do the same thing to everything, and I have y is less than a negative 1/2 x plus 3. To graph this, we just need an m and a b, and then we got to keep track of what kind of line we're going to have. M, the slope would be a negative 1/2, the y-intercept would be 3. So I would begin my graph at the y-intercept of 3, that's up 3 on the y-axis, and then my negative slope means I'm going to go down 1 over 2 each time. And remember what we talked about a lot last year, we want to actually try to fill this graph as we go. Really want to get a good picture of what this looks like. Then I'm going to go back and I'm going to look at my symbol of inequality, and I see that that's a less than symbol. So when I go back to my cheat sheet or my background knowledge, less than means we're going to have a dotted line because it cannot be equal to, and we're going to shade below that line. So what that means for my graph here, I'm not going to actually connect the dots. I'm just going to leave those dots. I have a dotted line, and I want to shade below because I want y values that are less than that line. I want y values below. And so again, we just had a nice, neat method of shading. We basically go across from the line, and again, we really try to fill up this graph and make it clear what we're looking at. That's a quick review of linear inequalities, but what we're all about today and what we're going to do a couple examples of on this video are systems of linear inequalities, systems of inequalities. So similar to systems of linear equations, the solutions to a system of linear inequalities are all ordered pairs that satisfy each inequality in the system. So they have to be true for each, whether that's 2 inequalities, 3 inequalities, the ordered pairs have to satisfy all of them. They have to be solutions of all of them. The nice thing about linear inequalities, we solve them and we give their solutions by graphing. If you can graph them correctly, that gives you your solutions, and then that's your answer. You don't have to do any work from there. We're just looking for ordered pairs that satisfy all of the inequalities in the system. So let's look at solving this system of inequalities by graphing. I have 2 inequalities. I have y is greater than or equal to x minus 3, and y is less than negative 3x plus 1. We'll start by just graphing the first one. So I'm going to graph y is greater than or equal to x minus 3. I see I have a y-intercept of negative 3, so I'll start there. And I have a slope. If I have a coefficient of x there, it would be 1, so I have a slope of 1. So I'm just going to go up 1 over 1 each time. And again, very important here that we try to fill this graph, really get a good look at what this line is going to look like. Go back and look at my system of inequality or my linear inequality. It says it's greater than or equal to. So notice this would be a solid line because it can be equal to these ordered pairs. And greater than makes me think that I will shade above. And so real quickly, I'll just do that same shading that I've done before. I'm shading everything above, everything greater than the line. These would be all the solutions for that first inequality that we have. Y is greater than or equal to x minus 3. Now, to solve the system, I'm simply just going to go back and graph the second one. Y is less than negative 3x plus 1. I would start at the y-intercept of 1. Notice I've changed my color here to try to make that clear. I have a slope of negative 3. That's down 3 and then over 1. And down 3 and over 1 and down 3 and over 1. I'll fill back the other way, really trying to fill this graph and make sure that I have it taken care of. So I'm looking for now, well, would this be a solid or a dotted? And as I see y is less than but not equal to, I'm going to leave this as a dotted line. I'll put arrows on my end. And now I'm looking for values where y is less than that line. Now this is kind of a tricky example, but if you look, I want below that line. To get below, I'm going to have to shade down underneath the line here. So as I shade, I'm showing all the solutions for that equation. That inequality. And what you now get is you see it's some very distinct areas that we talked about a little bit last year. Up in the top right, you see nothing but blue. This would be solutions for just the first inequality. If you look down towards the very bottom, you see solutions for just the second inequality. If you look over here in no man's land, obviously ordered pairs in this region here would actually not satisfy either inequality. But what we're really looking for is the solutions that satisfy both. And you can see that by where the red and the blue are both shaded. In here in this fourth region, those would be your solutions. Those ordered pairs satisfy both inequalities, and therefore they're the solutions of the system of inequalities. Let me give you one more example. Solve this system of inequalities by graphing. So you should have the idea that we're first going to just graph this. So I'm going to graph y is less than 2x minus 5. Start at a negative 5 and go up 2 every time because my slope is 2. I'm going to go back the other way just to make sure that I have this. That's a less than but not equal to, so I'm going to leave it as a dotted line, put arrows on it, and it's a less than, so I will shade below that inequality. Second inequality says y is greater than 2x plus 2. Hopefully we're starting to notice something already, but the y-intercept is 2, and we have a slope of 2, so we're going to go up 2 over 1, up 2 over 1 each time. One thing to notice then is we have parallel lines. Hopefully we're noticing that we have parallel lines. These aren't going to intersect. They don't cross. The other thing that we now notice, it's greater than but not equal to. Leave it dotted, and I'm going to shade above. And so I'd have every ordered pair that was greater than that line or above that line. So when I look at my graph here, it should become kind of clear. We were looking for ordered pairs that satisfy both inequalities, and there is not a set of ordered pairs that satisfy both inequalities. The red is all shaded above that line. The blue is all shaded below that line. They're parallel. They don't intersect. This means if there's not any ordered pairs that satisfy both, we have no solution, just like we've seen before. So a quick overview of solving systems of linear inequalities. Remember the nice thing about it, we're going to solve them and we're going to show our solutions by graphing. We also began with a quick review of just regular old linear inequalities, which also included some background knowledge on how to graph them using slope-intercept form and using their symbols of inequality. And then we did do a little quick double check on how can I check and see if an ordered pair is a solution of an inequality. That wraps up this video, that wraps up these notes, and that wraps up Unit 5.